Hello everyone, and welcome back to another daily LeetCode challenge. Today's problem is LeetCode 3573, best time to buy and sell stock V. You are given an integer array called prices, where prices I represents the price of a stock in dollars on the ith day, along with an integer k. You are allowed to make at most k transactions. Each transaction can be one of two types. A normie transaction means you buy the stock on day I and sell it on a later day j. Where I is less than j, the profit for this transaction is prices j minus prices I. A short selling transaction means you sell the stock on day I and buy it back on a later day j, again where I is less than j. The profit for this transaction is prices I minus prices j. There are a few important constraints to keep in mind. You must complete one transaction before starting another. You cannot buy or sell on the same day that is already being used as part of another transaction. Your task is to return the maximum total profit you can earn by making at most k transactions under these rules. This problem combines dynamic programming with careful state management. Let's go through the examples next to understand how both normal trades and short selling affect the profit. Let's walk through the first example to see how the profit is calculated. The input prices array is 1, 7, 9, 8, 2, and we are allowed to make at most 2 transactions. The final output is 14, meaning the maximum total profit we can achieve is $14. First, we perform a normal transaction. We buy the stock on day 0 when the price is $1, and then sell it on day 2 when the price is $9. This gives us a profit of 9 minus 1, which is $8. Next, we perform a short selling transaction. We sell the stock on day 3 when the price is $8, and then buy it back on day 4 when the price drops to $2. This gives us a profit of 8 minus 2, which is $6. When we add both transactions together, the total profit becomes 8 plus 6, which equals 14. That is why the final answer for this example is 14. Now let's walk through the second example. The input prices array is 12, 16, 19, 19, 8, 1, 19, 13, 9, and we are allowed to make at most 3 transactions. The output is 36, which means the maximum total profit we can achieve is $36. First, we perform a normal transaction. We buy the stock on day 0 at a price of $12 and sell it on day 2 when the price reaches $19. This gives us a profit of 19 minus 12, which is $7. Next, we perform a short selling transaction. We sell the stock on day 3 at a price of $19 and then buy it back on day 4 when the price drops to $8. This gives us a profit of 19 minus 8, which is $11. Finally, we perform another normal transaction. We buy the stock on day 5 at a price of $1 and sell it on day 6 when the price jumps to $19. This gives us a profit of 19 minus 1, which is $18. When we add all 3 profits together, 7 plus 11 plus 18 equals 36. That is why the final answer for this example is 36. Now let's break down this solution step by step and understand the idea behind it. This problem is more advanced than the classic stock problems because we are allowed to do both normal transactions and short selling, and we can do at most k transactions total. That immediately tells us this is a dynamic programming problem. Core idea. For every transaction count, we track 3 different states. The best profit when we are doing nothing, meaning no active position. The best profit when we are currently holding a stock after a buy. The best profit when we are currently holding a short position after a sell. So each transaction has 3 states, not just 2 DP table structure. We create a DP table like this, DP trans state, where trans is the number of completed transactions. State 0 means no position. State 1 means holding a bought stock. State 2 means holding a short position. Initialization. We initialize the DP table using the first day's price. No position starts with profit 0. Buying a stock costs money, so profit becomes minus the price. Short selling gives money upfront, so profit becomes plus the price. That's why we initialize each transaction row like this. No position, 0. Buy position, negative first price. Short position plus first price. This setup already reflects real trading logic. Iterating over days. Now we loop through each day. Starting from day 1. For every day, we check all transaction counts from K down to 1. We go backwards intentionally so that updates don't overwrite values we still need in the same day. State transitions explained. Let's look at how each state is updated. State 0, no position. We can end the day with no position in 3 ways. We were already doing nothing. We sell a previously bought stock. We buy back a previously shorted stock. So we take the maximum of those options. State 1, holding a bought stock. We can only reach this state by buying today. That means we must come from a completed transaction count 1 less than the current one. So we subtract today's price from the previous no position profit. State 2, holding a short position. Similarly, we enter a short position by selling today. Again, this must come from 1 less completed transaction. So we add today's price to the previous no position profit. This DP formulation cleanly enforces all constraints. No overlapping transactions. Each transaction is fully completed. Normal buys and short sells are both supported. Maximum of K transactions guaranteed. And most importantly, it runs efficiently in OK times K. Final answer. At the end, the maximum profit we care about is when we have completed K transactions. We are not holding any open position, so we return DP K0. This is a powerful dynamic programming pattern that generalizes stock trading strategies far beyond the basic problems. If you understand this solution, you are already operating at a strong interview level. All right, now that the solution is fully in place, let's wrap this up. First, let's run the code. Perfect. All the test cases passed successfully. That confirms our dynamic programming logic handles both normal transactions and short selling correctly. Now for the final step. Let's hit submit. And there we go. Accepted. All test cases passed. That brings us to the end of today's daily LeetCode challenge. If this deep dive helped you understand advanced stock DP strategies, make sure to like the video, subscribe to the channel, and share it with others preparing for coding interviews. I'll see you in the next problem. Happy coding!